Bismillahirrahmanirrahim. Welcome to Chandbagh School. Grade 11, lesson number 7. Dear students, again we are going to discuss the DC circuits and electrical circuits. Today our focus will be to problem solving. Uh, First of all, I'm going to uh, present you a diagram in which three resistors R1, R2 and R3 are connected, and it's a actually color coding. So from the color coding we will try to find the value of the resistance of each resistor, as well as we will find the current through each resistor and power dissipated by each resistor. In this diagram, the supplied battery supply is 4.5 volt. So now we will try to solve this. In To determine the solution, we need to first find the resistance of each resistor. According to the color code, each resistor is of the value of 1.102 ohm, because every resistor is of same color coding. So the each resistor R1 is equal to 102 ohm, R2 is equal to 102 ohm, and R3 is equal to 102 ohm. So in series the resistors are added. So the total resistance of this circuit will become R1 plus R2 plus R3 is equal to 102 plus 102 plus 102 is equal to 306 ohm. So this is the total resistance of the circuit, or equivalent resistance of this circuit. So instead of connecting three resistors in series like this, if we connect only one resistance of 306 ohm, then the purpose will be the same. So now we want to find how much total current is passing through the circuit, because this is a series circuit. So current remains same passing through each resistor. That will be I is equal to V over R. V is the battery voltage or EMF. So 4.5 divided by 306 is equal to 0.0147 ampere. So this is the amount of current passing through the each circuit, or passing through the circuit, each resistor or passing through the circuit. So but the voltage across each will be according to the each value of the resistance. So in this case, since the resistance of each resistor is same, that is R1 is equal to R2 is equal to R3, so the voltage drop across each resistor will also be the same. So V1 is equal to V2 is equal to V3. The formula for V1 is equal to IR1, as current in series remains same. So V1 is equal to 0.0147 multiplied by 102 ohm is equal to 1.5 volt. So 1.5 volt will be dropped across each resistor. Hence 1.5 volt plus 1.5 volt plus 1.5 volt, that will be equal to 4.5 volt. So across each resistor voltage drop will be 1.5 volt. Current through each resistor remain the same, that is 0.0147 ohm. The power dissipated across each resistor will also be the same. That will be P1 is equal to V1 into I, that is current. So 1.5 into 0.0147 is equal to 0.0221 watt. So similarly, P2 will be 0.0221 watt, and P3 is also 0.0221 watt. So this will be the power dissipated across each resistor. The total power should be the total current multiplied by the EMF, that is 4.5 multiplied by 0.0147. So that will be the total power, which will be equal to P1 plus P2 plus P3. So this was the series problem. Now again another series circuit with the different you see diagram R1, R2, R3 and R4. There are four resistors connected in series. They are connected in one line. So the battery voltage is 9 volt as a DC volt, and the color coding of each resistor is different. The first resistor is of brown, green, red and gold. So according to the color coding, the resistance of the resistor becomes 152 ohm. And similarly, the second resistance R2, that is yellow, violet, orange and gold, and that gives us 473 ohm. And R3 is red, green, red and gold. This becomes 252 ohm, and R4 is white, black, red and gold, that is giving us 902 ohm. So R1 150 ohm, R2 473 ohm, R3 252 ohm and R4 902 ohm. They are connected in one line, that is in series circuit. So what we want to find is that we want to find the voltage across each resistor and the current through the circuit. So before finding the current through the circuit, we need to find the total uh, you see the resistance of the circuit, that is R1 plus R2 plus R3 plus R4. So 152 plus 473 plus 252 plus 902, that becomes 1799 ohm. This is the total resistance of the circuit, and the current will be I is equal to V over R. So the battery voltage is 9 volt and divided by 1799, this is the total resistance. So 0.005 ampere will be the amount of current passing through the whole circuit. As we can see that the resistance of each resistor is different from each other. So the voltage across each resistor or voltage drop across each resistor will be different. So V1 will be IR1, V2 will be IR2, V3 will be IR3 and V4 will be IR4. So I remains same, that is 0.005, and the R1, R2, R3, R4 are different. So V1, V2, V3 and V4 will be different. So V1 will be equal to 0.005 multiplied by 152, that becomes 0.76 volt. So the voltage drop across R1 will be 0.76 volt. V2 0.005 multiplied by 473, this becomes 2.36 volt. And V3 0.005 multiplied by 252, 1 is equal to 1.26 volt. And V4 will be 0.005 multiplied by 902 ohm is equal to 4.51 volt. So the voltage drop across each resistor will be different. If we add up the voltage of all these four resistor drops, then this becomes V is equal to V1 plus V2 plus V3 plus V4 0.76 plus 2.36 plus 1.26 plus 4.41, that is 8.79. That is very, you see, close to the EMF. So it's this little bit difference. I need to ask you people that why this difference is. So this is how the four resistors in the series circuit problem can be solved. Okay, so these are the you see Third question, three questions of the different you see values and circuits. In question number 3, we need to find out the potential difference VA, that is between point A and the ground, and the second between the point B and the ground. So in this circuit we can see that there are two basically circuits. Two circuit means that they have different battery supply, that is 100 volt on one side and 100 volt on the other side, and the two circuits are in series, but these are two different loops. So in this case we need to find the voltage across VA and VB differently. So if we're taking the loop on the left side, that is V volt is 100 volt, then resistance 47 and 25 kilo ohms are connected in series. So we need to find the total resistance first. So the total resistance will be R total is equal to 47 kilo ohm plus 25 kilo ohm. That will be uh, equivalent to you see uh, 7 for 72 kilo ohm. So this will be the total resistance. Now the current passing through the circuit will be I is equal to V over R. So the 100 over 72 kilo ohm, the current becomes 0.00139 ampere. Hence the potential difference across VA will be I into RA. So RA basically is 47 kilo ohm. So this 0.00139 multiplied by 47,000, because it's a kilo ohm. So 47,000, this becomes 65 volt. Similarly, in case of the second loop, we need to find the total resistance, that is 33 plus 10, 43 kilo ohm. So the you see current will be I is equal to V over R. V is again 100 volt on the right side battery, and total resistance will be equal to 43,000. So I is equal to V over R. So 100 over 43,000 ohm, that can be calculated the total resistance. And when we get the total the total current, then we can find VB. VB is equal to IRB. So I will be the total current multiplied by 10 kilo ohm. Here is the assignment, and this is a very important question. We have already discussed these type of questions in lesson number 5 and 6, and also I sent you the assignment. So you are to find the difference when the load is connected across the R2 resistance. This is your assignment, and there are another 6 questions which relates to the basic formula I is equal to Q over T, uh, or Q is equal to I into T. Thank you very much.